All right, picking up where we left off, we are going to find the sum of the measures of the angles of a polygon with a certain number of sides. All right, so this is the formula, but let's talk about where this formula comes from. So let's suppose, for example, I have a quadrilateral right there, and I want to figure out how many, what's the degrees. Try again. The sum of the measures of the angles. Okay. So I don't know what a four-sided figure adds up to be, but I do know what a triangle adds up to be. So what I'm going to do is I'm going to divide this into two different triangles. So I know that this triangle has to add up to 360, and I know that this triangle also has to add up to I don't know why I said that. I know it has to, I'm getting my answer before the question. All right, it has to add up to 180 degrees. Sorry about that. 180 degrees. And because I have two of them, 2 times 100, there's my 360. All right, so a four-sided figure has to have 360 degrees. Okay. Now, if I have, let's see if I can draw a five-sided figure. That's the only way I can draw five-sided figures if it looks like a house. All right, so this time I am going to divide it up into triangles right there. And notice 180, 180, 180. Notice now I have 1, 2, 3 triangles times 180 for a five-sided figure. So I went from 5 sides down to 3 times 180. All right, let's do maybe one more. Hexagon. Use your imagination. All right, that's supposed to be a hexagon. All right, so again with my triangles. And this time, so I've got 6 sides. And let's see, did I get 6 sides or did I get 8 sides? 1, 2, 3, 4, 5, 6, 7, 8. Oops. This is an octagon. So now I have 1, 2, 3, 4, 5, 6. All right. So 6 of my 180 degree triangles. And notice I went from 8 sides to 6 times. So do you see where the n minus 2 comes from? I take the number of sides, subtract 2, multiply times 180. Number of sides times 2, or subtract 2 times 180. I'm really doing a lousy job on this video. Sorry about that, guys. Okay, find the sum of the measures of an octagon. Well, here we go. So we need to do 6 times 180 is equal to 6 times 180 is 1080. All right. Tessellations, another name, kind of an informal name of tessellation is tiling. And the reason why it's called a tiling, you guys know like floor tile, that's exactly what we're talking about. So you know with floor tile, there can be no gaps, and I'm not talking about for the ground. So if I have, like, probably the easiest floor tile is squares, right? I'm not going to have a gap here and then do continue with my squares, then I would have some weird thing on the floor and there would be nothing there. So that's not really how floor tiling works. You have squares, you have tiles that cover the entire floor, right? So that's the definition of tessellation. It consists of repeated use of the same geometric figures. So we could have, for example, two different shapes to completely cover, or we could use the same shape, or we have three different shapes. But the key here is it has to be repeated use, same geometric figures, completely cover, leaving no gaps, no overlaps. There you go. Much easier than this makes it sound. Now, the sum of the measures of the angles that come together at each vertex is always going to be 360 degrees. Well, I'll show you on a picture on the next slide why it has to be 360. The most restrictive condition is using just one type of regular polygon. For example, squares, right? They're all squares. Okay. I think you can also do it with hexagons. All right. So when we talk about the vertex, so each of these points right here, those are called vertices. We've got vertex, right? Well, where all of these come together, do you see how it kind of makes kind of a circle there? This angle plus this angle plus this angle have to equal 360 degrees. So for it to be a tessellation at the vertex, it has to add up to 360 degrees. So this angle plus this angle plus this angle plus this angle have to equal 360. Okay. All right. Guys, it looks like these are circles. They are not. Offhand, I can't tell how many sides they have. But visually looking at those, they look like circles, but they're not. They actually have sides. It just has a lot of sides, so it kind of tricks your eye into thinking that it's a circle. Okay. Explain why a tessellation cannot be created using only regular pentagons. Okay. Let's see. All right, so we've got a pentagon and I really suck at drawing. Pentagon and a pentagon. Okay, so the statement is, why can we not use regular pentagons to create a tessellation? Well, what we have to do is figure out what each of these angles is, and it's a regular pentagon. So we can divide it up into 3 triangles. And because it's a regular pentagon, all of the angles will be identical. So what we're going to do is take 180 and multiply it times 3. 180 times 3 is 540 degrees. And that would be the sum of all the angles. So all of the angles together, so all 5 of these would add up to 540 degrees. But since it's a regular pentagon, each one is going to be the same angle, the same measure. So we're going to take our 540, which is the sum, and divide it by the number of angles in our pentagon. So now we divide by 5, and each angle is 108 degrees. So this is 108. 108 degrees, this is 108 degrees, this is 108 degrees. All right, now when we add these up, okay, let's add these up. So we've got 108, 108, and I don't know how many of these I can have. So let's start with just 2 of these. So if I have 2 of them, that would be 216, which is not enough, right? It has to equal 360. So let's add another one. So 216 plus 108 would equal 324. Still not enough. So now we're at 324. So let's add another 108. But do you guys see if I add another 108, I'm at 432, which is over what I need. So 3 angles added together are not enough. And 4 angles gives me too much. I need exactly 360 degrees. So since it's impossible to get exactly 360 degrees, tessellation cannot be created using only regular pentagons. 108, and there you go.